All right, good morning. Super early streaming today. All right, so what are we doing today? Well, I have a hypothesis as to why it gets noisier when the support gets better. We're trying to satisfy the data consistency, and the data consistency has some noise in it. Normally, if we had all the data, that noise would be shoved outside of the support if we had full support. But since we're reducing the support, we must try to satisfy the noise in the data with a reduced area. So I think what's basically happening, the effect is that the noise outside of the support is being shifted to within the support. And so the better you make the support, the smaller you make it, the noisier it's going to become. So we're going to fix that. We're going to fix that by, instead of making values outside the support 0, we're just going to put them to within a noise bound. But that means we need a noise bound, so we're going to have to figure that out today. Also, I sort of realized a much better way to organize this code. So we're going to let the code do what we think the user wants it to do based on the parameters that come in. But A is going to change, the G function is going to change, F is going to change, all these functions are going to change. Basically, we're going to let different parameters imply that we're going to use different proximal operators, and that's what's going to happen. All right, so with that, let's get started. We really are going to start again. Okay. We've been streaming for 3.5 minutes already. We're going to take M. We're going to take FS. And at this point, I think we can do LSQR. Okay, so I'm going to need image 0. BSX fun. What's going on there? Oh, this is what's happening. So this is going to go away. Actually, it won't. So we're just not going to pass this in for right now. Still. Why? 354. Checks is passing. Oh, right, because LSQR assumes, right. Okay. I think that should do it. Okay, and that's model-based reconstruction for this highly undersampled data. Okay. Throws a bit of a wrench into the works that we have to like do this vectorization, devectorization. Might come up with just a different thing to do that. Okay. $20.25. It's been a road, hasn't it? Now, do we really want lambda? That was just a stepping stone in development on the way to developing this thing for gamma. I don't know that I want lambda. No one will ever use it. It'll take effort to support it. So we might not do that. And that simplifies that business of choosing between lambda and gamma quite a lot. But for now, so here's what's going to happen. This, was like, well, I'm debating. So here's what I'm thinking. By default, if we don't supply any parameters, then we run LSQR. Great. And it seems efficient to do that right now after we've just created MFS without doing anything more. But then we're going to have an if statement here that says, if parameter 1 is empty and parameter 2 is empty and parameter 3 is empty, etc., then do LSQR. And then we'll return right afterwards. Alternatively, we can go through and create all the functions. And then here we would say if NML support is greater than 0. And within here, we'll say return image. And here we'll take advantage of the support. Right. And then if we don't return here, then we just keep on going. I think this is going to be cleaner, so I think this is what we're going to do. It's all right. So we got here, right? Now we're going to take P. call that P. No, because we name stuff. Well, I don't know. Yeah, okay. Apply P. Fine. So if support is greater than 0, and the noise bound is either 0 or not provided, then we're going to do this. And this is going to say everything outside of the support is 0. Otherwise, we do this. I don't think I could create functions within a code I don't think I could create named functions within a code inside of if statements. So I don't think I could have if here function definition apply A, else here function definition apply A. So what are we going to do? Okay, so we're going to take MFSPT. That's what we're going to do. Now let's check MFSPT. And supports here. So this check has to come after that because we need and support for the check. We're always going to need end support for the check no matter what. If we're going to do this check for MFSPT. And since we're creating all of these linear transformations for whatever the input parameters are, we can do these checks no matter what. So we're just going to make end support. Okay. Let's see if that runs. Nope, 152. Why is that a bug? Because there is no image? Okay, that adjoint test passed. Great. We've got this running until this point. Now what? Now what? Now what? All right, so here's what I was thinking. else, just else. Now here we could still do LSQR, we're just going to do it with apply MFSPT instead. Okay, I'm tired of that. Vectorize. Is there a function called vectorize? Not recommended. Goodness gracious. I guess we'll call it vec dvec. This is going straight into worklib. I have to do this all the time. Oh, but now we need sizes too. Shoot. Dvec. Guess it's not going into worklib. Pretty tough. All right. So now I'm going to get rid of that and that. And for LSQR, so what I was going to do is just make it like here. Put the function here. It doesn't seem like I can do that because you have to pass in a function handle here. Okay. MFS, where is it? Function out equals apply VMFS. This is the vectorized version. This just vectorizes it. Right, okay. Yep, this is going to work, I think. Now this function I can put here in LSQR. Oh my goodness. Okay. We're going to need a vectorized version of MFS PT as well. PT. There we go. $96. Hmm? I don't know how that got there. Okay. Non-singleton dimensions. Looks like we need to add in some do checks. 182. Oh. We want a D back there. Which means we want to vectorize there. Right. Still buggy. User supplied function must return a column vector. Well, what do you think I'm doing? Clearly I need this in checks. And what is this? I think I called it SPVec. So this check changes based on, no, this is just the support. I mean, this is just, MFS assumes that the variable is the size of an image. All right, let's see if that passes. Okay, that passes. Well, then what's the issue? Oh, wait, that makes sense. For some reason, when I hit Command Option R right now, it's not running. Like MATLAB's not doing what I want it to do. 256, okay. We're using the vectorized version here. Right. That's what I wanted. Eight, 9, 3, 6, 8. Where did that come from? Where on earth did that come from? Oh. Yeah, this is not what I want. VecDVec, that did not work out as well as I had hoped. Okay. See if that passes checks. Yeah. Okay. This already outputs a column vector, I think. I see, that's the number of elements of B. Okay. So we don't need, wait, sorry. We only need it here. Let's make sure that passes. I was so excited to do this work. I couldn't sleep last night. Now I'm too tired to do it well, apparently. That's passing. Great. So we should still have LSQR. Now we need a similar thing for this. That's going to be out is equal to. So with this one, in now is a vector and out is a vector. So we don't need this, I don't think. Okay, so that's without the support. Now we're going to use the support and we're going to make it 0 outside. And that crashed. Why did that crash? Noise bound is unsupplied. Good, 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 good. We no longer have lambda. Gamma, noise bound support, 2 checks. Gamma's not being used because we're not there yet. Reshape. Reshape. LSQR failed. MFSPT. Where's the reshape? Oh, right. That didn't do it. Okay. We would only do this check if this is true. I could always get this back because it's in the other code. Okay, so that passed. In is a column vector, and out is a column vector. In is a column vector, and out is a column vector. Oh, okay. What is this error? Might be unused, right? Because it gets overwritten. Was that the issue? I forgot to return. Yeah, okay. Huh. Managed to put zeros even in the region we're calling the support. Seems like a large support to me. But, we need a support that, I'm calling it the support, but it's like actually a superset of the support. We need a designated support that's a superset of the actual support. Well, that's true. Okay. This is already going down a road that I don't want to go down. What I want to be able to do is just have a number of proximal operators defined and like iterate through them effectively. So I think we can do an anonymous function behind an if statement. So it then apply the data consistency portion of A. Actually, I could just do MFSSPT, else apply A DC is equal to MFS. And then here, we do this. Now we have the GC, the data consistency portion. I don't want that in both places. So let's see, what happens if I don't supply the support? Apply ADC is already a function handle. What's the problem? MFS does not exist. Oh. Error using BSX fun. Non-singleton dimensions. Oh, because we actually need a V, right? Apply VMFS. Okay. That's just model-based reconstruction. Now let's supply the support. Right, because now this is the simple way to do this. We'll see if we like this or not. Okay. So this is doing stuff. We're reconstructing an image with and without the support. Now, let's add one more parameter. Which one are we going to do? We got a whole bunch of problems up here. I guess we're going to do spirit regularization, aren't we? Okay. No, now we're going to do noise bound. So if noise bound is equal to 0, yeah, okay. Okay. we're going to make a function called gSupport. And it's going to be empty. So here, noise support, the NML of the support is greater than 0, but the noise bound has been provided, and the noise bound has been provided. So in this case, gSupport is equal to the indicator function that um, I guess I could do fro. And that's going to be within the noise bound. That's running off the screen at this font size. Okay. Now we need the proximal operator for this. And outside support is equal to but that only happens what happens if support's not supplied? Man, pretty tough. I'm doing this thing on my hand, so I'm looking at all 5 fingers and I say, okay, that's the size of the image. The support is 2. So 5 minus 2 is 3, which is this. Yeah, of course. Okay. It's always off by 1 errors that I've got to be aware of and protect myself against. We need an image. Now we've got it. Coming back down to prox gSupport. Okay, so this says that on average, the norm squared of a pixel outside of the support should be less than the noise bound. And so here we're going to do this projection that we've done so many times. R support noise ball is equal to square root and out support times noise bound. That's the radius of this ball. Variable value assigned to variable might not be used. Why not? Is it just because this is not being used? Yeah, okay. Twitch is a funny product. It's like, a gazillion-dollar company. But if I'm watching Twitch on my phone, which I do to monitor the chat, occasionally it just stops. The phone's plugged in, plenty of energy, just stops. Okay. We have now got one proximal operator, right? I might have to do something like dirty to do what I want to do. I think I figured it out. Okay. You'll see what's coming. It's tricky and dirty, and it works. And I don't know another way to do it. So there you go. Okay. So right now at this point, without a noise bound, G support H is empty and prox G support is empty, and that is fine. And so for right now, what I'm going to do is say if num_l. So here I'm going to say G is equal to G support H, and prox G is equal to prox G support. These two are going to change. These two lines of code are going to change later, but that's not what we're worried about now. If num_l G is greater than 0, then here we're going to do proximal. We're going to do PDHG. Just going to set verbose to true up here. By default. And if I ever get tired of the verbosity statements, then I'll change that. And if not, then everything's okay. People can change it if they want to. I'll even make it not hidden. I don't yet have a reason to use f. So it's still just the 0 function. So here, this will also be a part of this. Apply A. So going to apply A DC, because that's all we've got right now. Oh, no, 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 no. Where's apply A DC? Where does it get created? Inside there. Okay, so now there's a bug because apply ADC is only created when the support is greater than 0. Okay. We only want apply ADC to be this when we're using LSQR. Equivalently that. So here, All right. But what if the support is not greater than 0? I also need this, right? Well, yeah, but that's what I just did a second ago. Oh, there could be, okay, I'm so confused. The support is part of the data consistency term. Maybe. It is maybe part of this data consistency term. So if this will get overwritten if G does not get created, if G remains empty, right? If G remains empty, this will get overwritten here. And then this will use the vectorized version. But if G does get overwritten, then in comes apply MFS as the data consistency term. Now, why do I have this vectorized here? I don't know, but I don't like it. So we're just going to do that. Return image. Oh, right, return. Okay, so then the image that gets created here, that's what's going to get returned. Why is that an error? Might be unused. Well, of course. You want me to put it in here? I see. What? It's being used. Oh, don't need that. Okay. So now I think that if we supply a noise bound, which I'm just going to set a dummy variable for now. Just to see if stuff runs. G has got a handle. G support. It goes into here. Good, 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 good. Okay. Those things get defined. Opt-alg is not. Now this one I'm not going to expose. But we're going to need norm A. You know what? I haven't been recalculating norm A, but I think I've been changing it. Though over here, I don't think it mattered. here I could just put this right there. We don't need apply A, right? Though we are going to need an @ symbol. Yeah, okay. So apply A, DC. I'm just worried that I'm going to forget what DC means. So maybe I'll put the comment there, but then what if I'm looking here instead? I guess that's just the way it's going to go. I'll have to hope I see that comment. Is this running? Okay, so now I'm loading norm A, but this, of course, is a different norm A. What was the old value of norm A? 616, so it was higher. It didn't matter because we were using line search, I think. We just need tau to be like somewhere in the vicinity. Norm A finishes quickly. Okay. If it finishes that quickly, who cares? Let's just let it run. Yeah. I don't talk about X naught. Okay. Let's add in optional inputs. X naught. See how much that helped, that comment? That was an amazing comment. Okay, we're crashing. Why do we crash? Unrecognized function or variable G. How can that be? G is already a handle. Is that the issue? Arrays have incompatible dimensions. G support, really? Let's go. Let's see so this is the f of x plus g of ax. Let's see what's happening. Here's a, what just happened. Oh, first we're going to do f, apparently. That's 0. Now we'll do a. In. Okay. Now we're going to do g. Here, in is ax. Let's write down what problem we're trying to solve. So these two we've done. Oh, a is different, but that's the issue. That's the issue. Okay. I guess so. P takes an image and isolates just the pixels inside the support. So I guess we're going to say P complement X. So those are the values outside of the support, less than or equal to the noise bound, divided by an image minus n support. Okay, so for this problem, we need a different A. Or, wait a second, this can actually be, no. So this can be solved with Vista. We have a differentiable data consistency term. And a proximal operator that we know. Well, shoot. And then we can also add it. This can also be solved with Vista, can't it? This is differentiable. So what on earth was I doing before? Huh? What on earth was I doing before? Which means we're going to set the default optimization algorithm to empty. And the default will change based on whether we're going to call Vista or not. Oh, goodness. So at this point, without any more information, I can do this. Why was I squaring those things? It's least squares. Okay. So now we've got a constrained least squares problem, this one, where the objective function is differentiable. And the constraint can be modified to be a indicator, like we could add an indicator function to determine whether or not this satisfies this constraint. And then we can solve that with Vista, which is what we're going to do right now. Okay. So proxg support, good. Well, so when do I, oh, if the noise bound, right? That's what I need. If noise bound is greater than 0, not going to need apply A here. Let's open Vista with line search. Ooh, lots of parameters. I'm going to need, where's the proximal operator? Oh boy, oh boy, oh boy. I wish I hadn't gotten sidetracked with all this stuff. Okay. Are we going to use that or should I just get rid of it? It's also in the other code, so we're just going to get rid of this. See, okay, this is pretty tough, pretty tough. If numL f is greater than 0 and numL g is greater than 0, this will preclude, so here I'm thinking solve with Vista, right? But that will really preclude me from using f with PDHG. Is that an issue? I don't think it is, because you could always put You can always, whatever function you can form as f of x plus g of ax, you could form as g tilde of ax with a different a. So I think it's fine to say if f is greater than 0, then solve with Vista. Now the proximal operator is going to be different. And this is actually, oh, we don't need prox f, we need grad f. Apply A, dc, apply A, dc in transp minus apply A, dc, B transp. It's noise bound by default empty. Yeah, okay, so we could store that because we don't need it. It's just gets calculated once. I mean, it doesn't change, so we could just calculate it once, store it, and save it. Use it again. F grad. If nominal g is greater than 0, this is going to have to change when we start adding more and more constraints or different constraints. So let's do that up here. Right now, f can only be with the data consistency matrix inside of it. let's see how this goes. You know, Jonathan Blow says he builds for a while just to see what he's building. And he's willing to tear it all down and start again once he finds out what he's actually building. I think that's what I'm doing. Okay. F grad now prox G H. So I wrote the comments for Fista as though it were minimizing G plus G plus G of X plus H of X. So unfortunately, G to Fista is F to us and H to Fista is G to us. What are you going to do? What's the default inner product? That's the one I want. Let's see if that's actually the case. Good. And step NRST naught. Don't know what any of this stuff is. I mean, I think T naught's the initial step size. R and S might have something to do with line search and restart parameters. R, the backtracking line search parameter, as the scaling parameter used in each Fista iteration. Fista, yeah, this is also a line search. Restart, we will not use tolerance verbose. Okay. Yeah, verbose. Let's see what happens. Can't hover over. Didn't we define F? Yeah, right there. Noise bound. Oh, okay, so F is equal to, I'm gonna have to do that. Empty. Noise bound is 1, but F is empty. If noise bound not equal to 0 and noise bound is greater than 0. Well, even if it was 0, noise bound. Okay. We're gonna have to think about noise bound some more, because right now it's just right here. But that's going to change in a minute. So hopefully we'll be able to figure all this out. Okay, this crashes. And out support undefined. And out support. Unable to perform an assignment because left and right have different number of elements. This is an apply in M. They have different numbers of elements? That doesn't seem right. Image 0. Okay. F is that. F grad is that. At this point, we've calculated ATV, right? Okay. So we're just going to get to the place where Fista actually calculates stuff. See, where was it? Was apply MF ggrad in Vista at line 211. Oh no, that's the call to Vista. Line 169 here. Ggrad, y is 256 by 256. This should go right there. There we go. That's not working. No, that's not working. Where's prox G? Project onto ball in. G is the norm of in times support. Oh, complement. Stuff outside the support. Uh-oh. We call this X. Outside support is equal to X. Support equals 0. We just want to project the stuff outside the support. Out is equal to 0's S image. Wait, X support equals 0 is equal to okay. So that's what G was supposed to be. Only only the indicator function for the values outside the support, which means we got to change prox G. Function out is equal to again, I'm going to change this to X. X is equal to outside. Outside support is equal to X. Support equals 0. So we're just going to project the stuff outside the support. Okay. The indicator function does not, t times an indicator function is the same thing as the indicator function, so we don't use this t. We know that, but because of the way my codes work, they expect a parameter to be passed in, so everything's okay. I guess we need prox G support H. And when we call Vista, we're going to pass in prox G that prox G, but we needed to change that. Okay. Don't need this, but doesn't hurt anything. Don't need this for Fista. We're down here. So that makes more sense. We're just going to create the conjugate when we need it. Okay? How long have we been streaming? Wow, almost 2 hours. Time flies. Crashing. Objective values 1 equals g of x times h of x. All right, well, let's see what the problem is. Oh, G, that was silly. G is an indicator function, just outputs a scalar. Still broken. Still broken. Why? Let's run Fista. So Fista's simple. It just does a gradient descent step followed by a proximal step and then momentum. It's an ingenious invention, don't get me wrong, but it's simple. Why is that there? So we could just go, we could do a gradient descent update and then do a proximal step and see what happens, okay? Objective is 0. The objective here was 0. That seems wrong. And that seems like a bug, doesn't it? This should be a pretty easy bug to fix. Okay, so G has got to be, G has got to be 0, right? AX minus B. Okay. This seems to be working. Let's see what kind of image it makes. Okay. This should be about the same as MBR. It turns out that the noise bound is way too large. If we set the noise bound to something tiny, that's still too large? Uh-oh. No, that didn't happen. Okay. So if we set to tiny, it sets everything outside the support to 0, or to small, tiny to very, very small. But I wonder why it had to be so small. I think it's because we forgot to do a division by the number of pixels outside of the support in the proximal operator. That'd be my guess. How can I? Okay, finally. Yep. Oh, nope. Our support noise ball. Okay, yeah, I guess when we divide by the number of elements in the support, and take the square of a tiny number, that's going to be a tiny number. Okay. So 1 times 10 to the negative 8 basically did nothing. 1 times 10 to the negative 16th did something. 1 times 10 to the negative 12. I should get rid of that line. Maybe let's more stuff in? Maybe? These are just for debugging. So what I'll say is if verbose equals true, else and Vista, I think, with the data consistency term that is the L2 norm of AX minus B, which is what we've got. I think Vista also, like the step size needs, Vista, not Vista with line search, but Vista needs the step size to be less than or equal to the Lipschitz constant or 1 over the Lipschitz constant, something like this. Which I think for the L2 norm turns out to be the norm of A. I wonder if that's in my notes. Vista, I believe Vista is guaranteed to converge as long as step size satisfies 1 over L, where L is the Lipschitz constant. In the special case of this, we have, so we can take L to be A transpose A. Okay, the norm of A transpose A. Which of these things is the step size? I guess is T naught. T naught is equal to 1 divided by L. L, we're going to set to power iteration of ATA. Image not. Nope. Rand size image. What is ATA? ATA is equal to at in apply ABC Well, so what is F here? Yeah, okay. Apply ADC, apply ADC in transp. what crashed. Too many input arguments. MTMX. How is that possible? I don't know why MATLAB started making this beep. I remember I had to do something last time actually to get the beep to turn off at every step of the debugger. The fact that MATLAB has a beep in every step of the debugger tells you they are no longer using their own code. Oh, and now the beep is gone for some reason. Goodness gracious. Okay, so here, x0 is the size of the image. M is that. So the first thing we're going to do is apply ADC to x0. Apply ADC to x0. Unrecognized. Oh, I see. M. Okay, so that runs. Too many input arguments. Ah. Wait, ATA? I'm trying to tell it to do the transpose. Do I also need the transpose if it's symmetric? So there's a efficiency that we could take advantage of if it's symmetric. So if it's symmetric, yeah, now we no longer call with the operator transpose. Okay, so I'm just going to set symmetric equal to true for power iteration, and that should fix that. What's L? 1 times 10 to the negative 4, so now T naught, or 6 times 10 to the negative 4, so now T naught is 1 times 10 to the negative 5. That turns out to be about the values of T naught that we were working with, you see? Okay, so now this first time that we run Vista, you see how many sub-iterations we had to do? So now we'll be in the ballpark. So we saved those sub-iterations, but we had to call power iteration. But who knows how many sub-iterations we were going to have to do of the line search in order to get close. We know power iteration will work in just a few. And apply A does not seem to be taking very long, so this is what we're going to do. Okay, so we've got an image. It seems to be using the noise bound. Right now we're setting this noise bound by hand. We're going to not do that. So let's create a whole bunch of to-do items. Set noise bound automatically. Add in SPIRiT regularization. Add in compress sensing. And then we'll finally be back further than we were a little while ago. This is all because when we made the support smaller, things got worse. And that should not have been. And I think that happened because we were insisting on all the values outside of the support being 0. So now that's not the case. Now when we supply a support without a noise bound, we're doing this, which insists that everything's 0. So that's equivalent to the default value of the noise bound being 0. But if we supply a noise bound, then we're going to do this. Notice that this PT is no longer here. We're using P complement here. And that seems right. And so then we're going to say like other parameters include the following constraints as well. So if gamma is supplied subject to, well, if a scalar gamma is supplied, if a vector gamma is supplied, then we do this. I could keep going writing this code all day. Got a lot of other work to do. And you've been watching this stream for a long time already. We'll see if I stream later today. But if not, have a great day. And we'll make more progress next time. See you guys later.